Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. So, we have been talking about the expressions of the power, and here we have what we have done in the last class, that we have taken a small 2 bus example in which there is one generator bus and only one load bus connected through a line. And then we said that that particular system, 2 bus system, will be transformed into a equivalent 3 bus system. The third bus would be nothing but the internal bus, and then we have looked into its y bus matrix formulation, and then after that we have taken an example of writing down the expression of injected power at bus 2 corresponding to phase A for this system. And there we have noted down that this particular expression will have total 3n, that is 3 into 3, because now my total number of buses is 3. So, then therefore, it would be total number of elements in that expression would be 9. So, this is the expression. So, now in this example, so let us list down that what would be theta. The theta would be, what would be the theta vector? Theta vector is theta 1 is the, so theta vector is nothing but theta 1b, theta 1c, theta 2a, theta 2b, theta 2c transpose, right. So, this is the, this is actually the theta vector. So, now here we also have to understand, so in this and then what is the v vector? V vector is v1a, v1b, v1c, v2a, v3a, v2a, v2b, v2b. v2c transpose, right. What is theta internal vector? Now, because there is only one internal bus, so then therefore theta internal vector also constitutes only one internal angle. So, then therefore theta internal vector is basically theta 3a, right, transpose. Similarly, v internal vector is only constituting of only one quantity, that is v3a, right. Now, if I say that theta 3a is equal to theta internal 1 and v3a is v internal 1, then I can say that theta internal vector is only theta internal 1 and v3a, and v internal vector is v internal v internal 1, right. So, these are the, now we have to understand that theta 3b, now in the expression of this, p2a, we have got theta 3a, theta 3b, theta 3c. We also have got the values v3a, v3b, v3c. But then because bus 3 is an internal bus, so then therefore I know that theta 3b is actually theta 3a minus 2 pi by 3. That means I can say that it is theta internal 1 minus 2 pi by 3, that I know. And theta 3c is theta 3a plus 2 pi by 3, that means theta internal 1 plus 2 pi by 3, right? And V3b is equal to V3a is equal to V internal 1. Similarly, V3c is equal to also V3a is equal to V internal 1, right? So, these relations are for the internal buses. And so, now if I now use these relations for these internal buses and substitute it, so if I now substitute it P2A, so what do I get? So, P2A would be, please note that theta 1A is 0, right, and also we have taken that theta 1A is essentially an it is actually known quantity. So, V2A, so it is V2A, V1A, Y21AA cosine theta 2A minus theta 1A is 0. So, minus 0, say alpha 21 AA, then plus V2A V1B, V2A V1B, V2A V1B, Y21 AB cosine theta 2A minus theta 1B minus alpha 21 AB, then it would be J is equal to 1, L is equal to C, plus V2A V1C Y21 AC cosine theta 2A minus theta 1C minus alpha 21 AC plus V2A. Then I have got J is equal to 2, L is equal to A. So, V2A whole square. So, here it is, you see, so when J is equal to 2, L is equal to A. So, this V2A whole square Y22 AA cos theta 2A cos theta 2A. So, this you see this will cancel out, this will cancel out, and cos minus alpha 2A is actually cos alpha 2A. So, I can say that it is G22AA, right. So, I can say that is V2A whole square into G22AA, right, plus then V2B and V2C, V2A, V2B, Y22AB cosine theta 2A minus theta 2B minus alpha 22AB plus V2A, V2C, Y22AC cos theta 2A minus theta 2C minus alpha 22AC. So, second bus is taken care of. Now, the third bus V2A V3A. V3A, I am saying that it is V internal 1A. So, V2A V internal 1, then Y23AA Y23A cos theta 2A cos theta 2A minus theta internal 1, because theta 3A we said that it is theta internal 1 minus alpha 2 3 a, right, alpha 2 3 a, then v2a v3b plus v2a v3b is also equal to v internal 1. So, v internal 1, then y23 ab cosine theta 2a minus then theta 3b is v internal 1, sorry, theta 3b is so minus theta internal 1 plus 2 pi by 3 minus alpha 2 3 ab, correct, and then v2a. So, this is for v3 is equal to, so j is equal to 3, L is equal to b. So, now v2a v internal 1 1 y 2 3 ac cosine theta 2a minus theta internal 1 minus 2 pi by 3 minus alpha 2 3 ac. So, now we have replaced everything in terms of our known and unknown quantities. So, here only thing is that we have said that where we said that because we are using this, so then therefore should say that where any yij pl, right, any yij pl is equal to gij pl plus j bij pl, right. So, this is the admittance part and this is the conductance part and this is the susceptance part. So, using that we said that y22a basically, so essentially that means GIJPL is equal to YIJPL cos alpha IJPL and BIJPL is equal to YIJPL sin alpha IJPL, right. So, this is the real part and imaginary part. Okay, so this is now my expression of P2A. So, again I do have 9 terms 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, let us do what is, say now I have got 4 cases. So, first case is that case 1 is that I is not equal to j and p is not equal to L. So, that was the first case. So, let us say that I want to find out del P2A by say del theta 1 c, right. I is equal to not equal to j and p is equal to not equal to L, right. So, now let us see that del P2A by del theta 1 c, how many terms has got theta 1 c? Only one, this one only, and then no other term will have theta 1 c, theta 1 c, no other term will have theta 1 c. So, then therefore, if I take this partial derivative, so I need So it would be V2A, V1C, Y21AC sine theta 2A minus theta 1C minus alpha 21 AC, right. Cosine has got a derivative minus, and but I have got theta 1C also, there is another minus, so both minus becomes a plus, right. Similarly, if I do, let's say, del P2A by del theta 1B, let's say for example, then I will have V2A, V1B, Y21AB sine theta 2A minus theta 1B minus alpha 21 AB, right. So then therefore in general, I in general del PIP by del theta JL with the condition that I is not equal to J and P is not equal to L, that would be is equal to VIP, right, then VJL, correct, because here J is 1 and L is C, then Y I J P L sine theta I P minus theta J L minus alpha I J P L. So that would be the case, because here I is equal to 2, P is equal to A. So I is equal to 2, P is equal to A, and J is equal to 1 and L is equal to C. So this is it, 2 1 AC, PL is AC, and then theta 2A, theta JL, etc. Right. So this is the case number 1. So this is case number 1. Right. What is case 2? Case 2 is I is equal to J and P not equal to L. So this is case 2. That is what we said. I is equal to J, P is not equal to L. So therefore, P2A, say let theta 2 B, right. I is equal to J, but P is not equal to L. So that means the bus indices are same, I and J they are same, but the phase indexes they are not same. So let us see that how many terms has got theta 2B. So theta 2B has got only one term, theta 2B, right. No other term has got theta 2, right. No other term has got theta 2. So then therefore this partial derivative would be V2A, V2B, Y22AB. Then cosine has got derivative minus sine, and theta 2 from theta 2 I will have another minus, so minus times plus. So it will be V2A, V2B. So it will be V2A, V2B, right, Y22 AB cosine theta 2A minus theta 2B minus, sorry, not cosine, sine alpha 22 AB, right, sine. So that means in general del PIP by del theta JL, condition I is equal to J and P is not equal to L, there will be only one term, that would be given by VIP, VJL, YIJ, j PL sine theta IP minus theta JL minus alpha ij PL. So that would be the case VIP BJL YIJPL sine theta IP minus theta JL minus alpha ij PL, right. So this is the case in case 3. Case 3 is I is not equal to J and P is equal to L. So this is case 3. So that means del P to A del theta 3A. P is equal to L but not theta 3, theta say 1. But then here in this case actually theta 1A will not exist, right. Theta 1A will not exist. I is not equal to J and P is equal to L. So P is equal to L. So now here it will be theta 1A, it does not exist, correct. So I should have written an expression of P to B, right. I should have written down an expression of P to B. So then that would have been the case. Anyway, doesn't matter. So case 3 doesn't exist. Here in this case, case 3 doesn't exist. I will show that what would be case 3 for this. Let us go for case 4. Here in this case, case 3 doesn't exist actually. I is not equal to J but P is equal to L. P is equal to J L. Now there are only 2 buses, 2 and 1. I have already taken 2. So I can only take 1. Because phase is A, so phase A, but theta 1A doesn't exist in this formulation, so it doesn't exist. So if I take P to B, the expression of P to B, then and only then it would be theta 1B. So we will just do it. So to do that, let us do it. Right, case 4 let us do first. Case 4. Case 4 is I is equal to J and P is equal to L. That means del P to A by del theta 2A, right. So del P to A by del theta 2A we can see is that it exists everywhere except this term. It exists everywhere. So del P to A by del theta 2A exists everywhere except this term, that is this V2A whole square G2 2A, that doesn't exist. Other than that it exists everywhere, correct. So then therefore del P to A by del theta 2A would be actually given by minus, so all the terms would be existing except this term, right. All the terms will be existing, right, because this term all has got theta 2A, this term has got theta 2A, this term has got theta 2A. So all the terms will be existing and all of these terms partial derivative would be minus sign. So then therefore there will be a common minus sign, and because theta 2A is positive, so it will be minus sign and everything else would be the same. So then it would be essentially, so if I collect all the terms except this one, so it will turn out to be, it is very easy to see that it would be minus L is equal to A, B, C, then J is equal to 1, 2, 3, then V2A VJL Y2JAL sine theta 2A minus theta JL minus alpha 2JAL, right. So, alpha 2JAL, right. What is the condition? Condition is that here the condition is that either I is not equal to J or P is not equal to L or both. That is the condition. If both I and J, if both I is equal to J and P is equal to L, that term does not exist, right. For all the other cases it exists. So, either I is not equal to J or P is not equal to A or both, right. So, under this condition this, right. So, this is only not true for when I is equal to J and P is equal to L. So, in this expression the essentially in this expression the term corresponding to I is equal to J and P is equal to L will not exist, but all the other terms will exist. So, for this term in this case in which either I is equal to J or P is not equal to L or both. So, then therefore, in general uh, del PIP by del theta IP would be is equal to minus L is equal to ABC, J is equal to 1 to N plus M, right. Then VIP VJL YIJPL sine theta IP minus theta JL minus alpha IJPL. So, that is the general case, and where either I is not equal to J or P is not equal to L or both. So, in this, so this is the condition. So, this is the condition. So, this is the condition. Now, case 3 is remaining where I is not equal to J, but P is equal to L. So, for that we have to write down the expression of some other expression. So, in any case, so if we write down the expression of P to B, let us write down the expression of P to B, then it would be okay. So, P to B is L is equal to A B C, J is equal to 1 2 3, V to B, then VJL Y to JBL cosine theta 2A minus theta 2B, sorry, theta 2B minus theta JL minus alpha 2JBL. So, if I keep on expanding V2A, V2B, V1A, Y2 to 1 BA cosine theta 2B minus theta 1A is 0 minus alpha 21 BA, right? Then theta 1B, then V2B, V1B, Y21 BB, then cosine theta 2B minus theta 1B minus alpha 1 BB plus V2B, V1C, Y21 BC cosine theta 2B minus theta 1C minus alpha 21 BC, right? Plus V2B, then J is equal to 2 and L is equal to A. V2A, Y22BA cosine theta 2B minus theta 2A minus alpha 22BA, right? Plus V2B, and J is equal to 2 and L is equal to B, so it will be V2B whole square, then Y22BB cosine theta 2B minus theta 2 alpha 22BB, so it would be G22BB plus V2B, V2C, Y22BC cosine theta 2B minus theta 2C minus alpha 22BC plus V2B. Then V3A is V internal 1. So V internal 1 Y23BA cosine theta 2B minus theta 3A. Theta 3 is theta internal 1 minus alpha 23BA, right? Then plus V2B, then V3B. V3B is also V internal 1, then Y23BB, then cosine theta 2B, then minus theta 3B. Theta 3B is nothing but theta internal 1 minus 2 pi by 3. So it is minus theta internal 1 plus 2 pi by 3 minus alpha 23 BB plus last is V2B, then V2B and then V3C. V3C is also V internal 1. So V internal 1, then Y23BC, then cosine theta 2B minus theta 3C. Theta 3C is nothing but theta internal 1 plus 2 pi by 3. So it is theta internal 1 minus 2 pi by 3, then minus alpha 23 BC. Right? So this is the expression. So now here, if I now try to do case 3, then it is I is not equal to I is, so case 3 would be I is not equal to J and P is equal to L. I is not equal to J and P is equal to L, right? So then therefore it would be del P to B, let us say del theta 1 B, right. I is not equal to G, but P is equal to L. So how, where is del theta 1 B? There is only one term theta 1 B, right. So del, so it would be V2 B, V1 B, Y21 BB sine theta 2B minus theta 1B minus alpha 21 BB, right. So in general, del PIP by del theta JL with the condition I is not equal to J, P is equal to L, that would be is equal to BIP BJL YIJPL sine so this is the case. So now we have got 4 expressions. So now with these 4 expressions, we will now generalize the all the expressions for the G1 matrix, and then afterwards we will go to the other matrices. So we will do that in the next lecture. Thank you.